Assalamu alaikum. Today in this chapter we are going to study transport level security, which is one of the very important protocol that is used for web security. As we know that nowadays um, so many businesses, uh, many of the government services and all other are going online, or they are giving us web applications. So and these companies and government is using internet for different services, especially for the e-commerce websites. So for these kind of services we need a proper security for these web applications, and one of the basic protocol that is used to provide web security is TLS protocol, or transport level security protocol, or we also call it SSL. So in the previous chapter we have discussed network layer security. So now we are going to discuss transport layer security. There are basically three main protocol that is used to provide security on transport layer, which are TLS or SSL, HTTPS and SSH. www or World Wide Web is a client server application which is running over the internet, and internet is following TCP/IP infrastructure or TCP/IP protocol stack. As such, the security tools and approaches that we have discussed so far are relevant to the issue of web security. However, there are the following characteristic of web usage which need for a specialized security tools for web applications. We know that it is easy to use a web browser, and it is also easy to configure and manage the web servers, and web contents or web applications are also easy to develop. But the problem is the underlying software which is used to do all these activity is extraordinary complex, and this complex software may have hidden many possible security flaws from the people who are using it. And we have seen that there are so many attacks and vulnerabilities are there in the applications, and we need to upgrade the systems to avoid these variety of security attacks and vulnerabilities. A web server can be used by the attacker to launch a kind of different type of attacks on your company, and once your web server is compromised, then attacker may be able to get access to the data and system that is not part of the web server itself, but connected to the server at the local site. So it is very important to properly secure those systems in your organization which are exposed to the outer access or internet user access. Another important factor that is need to be considered is that the people who are using these web applications or websites, they are not trained user with respect to security. So they are not aware of the security risks that exist in those websites, and they do not have a proper knowledge or tool to implement any effective countermeasure to protect themselves from these security risks. Okay, here this table summarize the type of security threats faced when using the web, and then we categorize them with respect to different security applications and what are the threats with each of these security services. We can say not application but security services, and what are the possible consequences and countermeasure for each. Like the threats that are related to the integrity service, we know that integrity is related to prevent the unauthorized modification of information. So the possible threats can be somebody can modify the user data, or Trojan horse browsers, or modification of memory, modification of message traffic in transit. What will be the possible consequences if these threats become a possible attacks? It can possibly be let you loss of information, compromise of machine, or vulnerability to other kinds of threats. And the possible countermeasures for these threats are: you can use cryptographic hash algorithm to calculate the checksum of your messages, so that on the receiving side you can always make sure that the message that you receive is not modified on the way. Then with respect to confidentiality, we know that eavesdropping, theft of information from server and some others. And the consequences is you will the loss of information and loss of privacy. And what are the possible countermeasure is, like whenever you want to make your data confidential, what you should use, you can use either encryption or web proxies. Similarly, for denial of service, it's the attack on the availability service. So denial of service attack, if it is there, attack on your service. The possible threat is killing of user threads, flooding machine with bogus request, and filling up disk or memory. But and the possible consequences is, like when your service is not available, it results in disruptive, annoying, prevent user from getting work done. And this is one. And the possible countermeasure for this type of threats is difficult to prevent. uh, and then we have authentication. The possible threats on authentication services: somebody can masquerade by impersonating as a legitimate user, or can perform data forgery. The consequences will be misrepresentation of the user, or belief that false information is valid. Integrity is related also to that. And for this, we have different cryptographic techniques which provide us user or message authentication. In order to provide web security, there are many possible approaches are there. And these approaches that have been considered are similar in the services they provide, and to some extent in the mechanism that they use, but they differ with respect to their scope of applicability and their relative location within the TCP/IP protocol stack. Like you can see that if you are going to implement security at the network level, okay, you can provide web security even on the network level by using IP security. On the transport level, if you are providing web security, then you are going to implement security on the transport layer using SSL or TLS. And you can also provide on application level by using protocol like here SMIME and Kerberos. Okay, transport layer security is one of the most widely used security service, and the current version is version 1.2, which is defined in RFC number 5426. It is an internet standard that evolved from a commercial protocol known as SSL. So before TLS, the protocol that is the base of the TLS is SSL protocol. There were some vulnerabilities and it has been improved and then evolved to TLS, or transport layer service protocol. And right now, okay, TLS protocol service is implemented as a set of protocol. It is not just a one protocol, it is a security service which consists of a set of protocol which are implemented on top of TCP. Okay, we on transport layer we have TCP and UDP. So TLS implemented on top of TCP, not on top of UDP. And we have two implementation choices for TLS. One is for full generality, that is full implementation. When we are going to do for this full generality version, then TLS could be provided as a part of the underlying protocol suite, like IPsec, and it is transparent to the applications and users. But it can also be embedded into specific package, like there are browsers that comes equipped with TLS, and some web server also implemented the TLS protocol. TLS protocol work on the top of TCP protocol, which is a reliable end-to-end protocol TCP, and when we use TLS on top of it, then it provide us reliable end-to-end secure service. And TLS by itself is not a single protocol, it is instead a set of protocols which are implemented on two layers as shown here, like IP protocol on network layer, transport layer we have TCP protocol, and then this is our application layer. And record now, as I told you, TLS is a set of protocols, so this is the set of protocol on these two layers, where one is on the transport layer, this one is on transport layer, and these are on the application layer. On transport layer we have on the top of TCP is TLS record protocol, which provide basic security services to many higher layer protocols, particularly HTTP protocol. When we say HTTPS, it is running on top of record protocol because it provides transfer service for web client server interaction and operate on top of TLS. So this is the record protocol that is above TCP protocol and on transport layer, and then we have three higher layer protocol which are defined as part of TLS, which are handshake protocol, chain cipher spec protocol, and alert protocol, where the handshake and we are going to discuss these protocol in detail in the coming slides. And then there is a fourth protocol, that is heartbeat protocol. It is defined in a different RFC or separate RFC and will be also discussed in this chapter. With respect to TLS architecture, there are very important two concepts are there, which are TLS connection and TLS session. TLS connection is a transport that provide a suitable type of service, and these connections are peer-to-peer relationship. They are transient, mean temporary, and connection cannot survive independently. They must have to associated with one session. So it means in order to have TLS connection, you must have to establish TLS session. So what is a TLS session? It is an association between a client and server. So you see, connection is peer-to-peer relationship, but TLS session is a association between a client and server. And sessions are created by a handshake protocol. Session defines set of cryptographic security parameters, like what are the keys, what are the algorithms that are being used on multiple connections between client and server. And why sessions are created before connection? Because we want to avoid expensive negotiation of new security parameter for each connection, because you just agree on security parameters during TLS session, and then those security parameters can be used on multiple TLS connections. So in other words, we can say that connection is a live communication channel, and session is what? Is a set of negotiated cryptographic parameters. So it is possible that a connection may finish after some time, because connection if remain idle for some time, then server will finish that connection, or that connection is die. But even if a connection dies, you can resume, or you can come back again with a session, because session still is there, like cookies in case of HTTP protocol. Between any pair of parties, there may be multiple secure connections, but there will be a one session. So first session need to be established, and under that session multiple connections are established. In theory, they said that it is possible that you have multiple simultaneous session also between same set of parties, but this feature is not used in practice right now. Okay, session state is defined by the following parameters. There are many states that are associated with each session, like established state, and also like pending read state or pending write state. So there are number of states that are associated with each session. So how can we identify the session state? It is identified by or defined by these parameters, like session ID. It is an arbitrary byte sequence chosen by the server to identify an active or resumable session state. Then we have a peer certificate, which is X509 version 3 certificate of the peer. It can also be null as well. Then compression method, the algorithm that is used to compress data before encryption, but compression is optional, but if you are using it, then which compression algorithm is being used. Cipher specification or cipher specs, which specify the bulk data encryption algorithm like AES or DES or any other, and hash algorithm that is going to be used for MAC calculation. Then we have master secret. Yes, it's important. It is 48 byte secret shared between the client and server, and this master secret is important with respect to key management, key distribution among parties who are in the communication. And then is resumable is a flag which show whether the session can be used to initiate a new connection or not. Okay, there are some other parameters through which a connection state is defined, the one that we have already discussed here, and then there are okay, these are for session state. Okay, and then connection state. You know, we have sessions. First establish a session, and then we establish connection. So how the connection state is defined? It is defined by these parameters. First is server and client random number, which is a byte sequence that is chosen by the server and client for each of the connection. So each connection have its own server and client random number. Server write MAC secret is the secret key which is used to calculate the message authentication on data that is sent by the server. And same is client write MAC secret is the secret key which is used for MAC calculation on data sent by the client. Server write key is the secret encryption key for data that is encrypted by the server and decrypted by the client. Okay, that is server write key. Server write key means server will encrypt data with that key and client will decrypt with that key. And client write key is the symmetric key again for data that is encrypted by the client and decrypted by the server. So it means server write key and client write key, both client and server need to know both keys. One key is used by server for encryption, another key is used by client for encryption, but both need both keys for decryption. So both parties need to know these keys, server write key and client write key. IV or initialization vector, when a block cipher in CBC mode is used, then IV is maintained for each key. This is what you know, that we need IV when we are using CBC mode, and this field is initialized by TLS handshake protocol, and thereafter the final ciphertext block from each record is preserved for use as the IV with the following record. Sequence number, each party maintain a separate sequence number for the messages that are transmitted or received on each connection. And when a party send or receive a change cipher spec message, because you know there is one protocol in TLS suite is change cipher spec. So change cipher spec, we use change cipher spec message in this protocol. So when party send or receive this message, the appropriate sequence number is again set back to 0. Another thing is sequence number should not exceed up to maximum limit 2 raised to the power 64 minus 1. Okay, TLS record protocol provides these two services, which are confidentiality and message integrity. If you look here, this is our TLS record protocol, which is on top of TCP protocol. And here we have handshake protocol. So TLS record protocol provides confidentiality. How it provides confidentiality? Because through the handshake protocol, when a connection is established, then keys are shared, you know, session is established, and after that connection is established, then shared secret keys are shared among both parties, and then these keys are used by record protocol for encrypting all the messages that are being sent on this session. And then message integrity or is provided through TLS record protocol, because through handshake protocol, when we define shared secret key, then those keys are used by record protocol to create or calculate the MAC of all the messages that are sent on that session. Now, how these both services are provided by TLS record protocol? Here in this diagram we show the overall operation of providing confidentiality and authentication service by record protocol. So what it do is the application layer generate a message and send it to the record protocol on transport layer. So record protocol will just first create the fragments out of it into manageable block, and then compress each of these fragments. Okay, compression is optional whether you want to use it or not, but if you choose option to use compression, then first these fragments will be compressed, and after that a MAC is calculated for each of the compressed fragment and added with this compressed fragment. And then after MAC calculation, we perform encryption on this compressed fragment and MAC both, and then data will be encrypted. So first MAC, then encrypt, and MAC is calculated either on fragment directly or compressed fragment if we choose the compression option. And after MAC calculation, data is encrypted, and after encryption it added or append TLS record header with each of the fragment. Fragment maximum size is 2 raised to the power 14 byte. So whatever your application message is, it is divided into fragment or divided into chunks of block, and each block size is, or each fragment size is maximum 2 raised to the power 14 byte. It is possible when we are using mode of some particular mode of operation for encryption which require blocks to be a length of multiple of block length, then we might have to add padding. So padding may be added after MAC and before encryption. And when we add padding, then we add 1 byte which show the length of the padding, and padding can be any amount that result in a total, that is multiple of the cipher block length up to maximum of 255 bytes. So if you are doing padding, then padding will be done after MAC and before encryption. So as I show you that after encryption, record protocol add a header. So now we will discuss what are the fields in these headers. The TLS record protocol header consists of these fields. First is content type. The length of this field is 8-bit, and it shows the higher layer protocol which is used to process the enclosed fragment. And then we have major version, again 8 byte, which show the major version of TLS that is in being used. Like for TLS version 2, the value for major version is 3, and minor version show the minor version of TLS that is being used, and for TLS version 2 the value for minor is 0. Compressed length, the length in byte of the plain text fragment or compressed fragment if compression is used. If compression is not used, then here it is normally the length of the fragment, but if compression is used, then after compression what is the length of the compressed fragment. And maximum value that you can add over here is 2 raised to the power 14 plus 2048. And content type, as I told you, that it shows you the higher layer protocol that is used to process the enclosed fragment. So content type can be like on higher layer after record protocol, you can have handshake, change cipher spec, alert, HTTP, heartbeat. So this content type field in the header tells you that what type of higher layer protocol is used to process this message. Okay, then here in this diagram we show the TLS record protocol payload. This is payload, this thing. So this is header and this is payload. So this payload depends on the content type. If content type is change cipherspec, then payload consists of just 1 byte. It is the simplest protocol which use TLS record protocol, and this single byte will be used and it has a value 1 in it. The main purpose of this message is to cause the pending state when we are creating a session through handshake protocol. Then we use this change cipherspec protocol to change the pending state to be copied into the current state, which updates the cipher suite to be used on a particular connection. If okay, this is one type of payload. The second type of payload that can be there with record protocol, like here we have a header record protocol, and type of payload can be alert protocol. The alert protocol is used to send TLS related alerts to the entities between each other, and both entities send TLS related alerts to each other through alert protocol. Alert messages are also compressed as well as encrypted. And then the third type of content can be handshake protocol, or payload is handshake protocol. Okay, one thing I forgot to tell you with respect to alert protocol. Alert protocol consists of two bytes. One is level, another one is alert. The first byte takes the value either a warning or fatal. So level can be warning or fatal to convey the severity of the message. If the level is fatal, if the level is fatal, TLS immediately terminate the connection, and other connection on the same session may continue, but no new connection on this session may be established. And the second byte contain a code that indicate a specific alert. The most complex part of TLS is the handshake protocol. This protocol will allow the server and client to authenticate each other, and then to negotiate encryption and MAC algorithm and cryptographic keys that are going to be used to protect data in a TLS record. So the handshake protocol is used before any application data is transmitted, because handshake protocol will negotiate all the cryptographic parameters that are being used on that session. Okay, handshake protocol consists of a series of messages which are exchanged between client and server, and we will discuss it in more detail in the coming slides. Other upper layer protocol that can be used as a payload of record protocol are HTTP protocols. So the first field in the handshake protocol is the type. So there are different type of messages that are exchanged between client and server to establish cryptographic parameters, and they both authenticate each other. So type of messages are given over here. Then there are 3 bytes which show the length of the message in byte, and then content. This parameter is related to the message. Like here we can see in this table we have different type of messages.